So this is where we left off last week on Friday. We had talked about the pH scale and how the pH is the negative log of the hydrogen ion concentration. Well, there's also a pOH scale. And pOH is the negative log of the hydroxide ion concentration. So you can think of P as meaning negative log of. P whatever is negative log of whatever that species is. Okay, so we're going to derive the relationship between pH and pOH. Some of you will like this and some of you won't. It's fine. You can't please everybody. So we said that Kw, which is the equilibrium constant for an acid-base, for the self-ionization of water, that's what they call it, was the hydrogen ion concentration times the hydroxide ion concentration. And that equaled 1.0 times 10 to the minus 14. Remember that? So what I'm going to do is I'm going to take the log of both sides of this equation. When you take the log of two numbers that are multiplied, you add the logs. So the log of the hydrogen ion concentration plus the log of the hydroxide ion concentration is equal to the hydrogen ion concentration times the hydroxide ion concentration. And then over here, I'm going to take the log of 1.0 times 10 to the minus 14. What's the log of 10 to the minus 14? It's minus 14, right? I don't like negative numbers, so I'm going to multiply everything by negative 1. So this is going to be plus 14. This is going to be minus log of the hydrogen ion concentration minus the log of the hydroxide ion concentration. What's the negative log of the hydrogen ion concentration? It's the pH, right? And the negative log of the hydroxide ion concentration is the pOH. So pH plus pOH equals 14. I'm not going to ask you to derive that. But that is a nice, simple relationship that we can use. So, calculating hydroxide ion concentration from the pOH. Calculate hydroxide ion concentration for a solution with a pOH of 4.25. Whoops. So, pOH equals 4.25. How did we do this when we were trying to find the hydrogen ion concentration from the pH? Do you remember that equation? Hydrogen ion concentration equals 10 to the negative pH. Anybody remember that? Well, it's also true if you just swap out hydrogen ion for hydroxide ion. The same relationship. So if we want to find the hydroxide ion concentration, we need 10 to the negative pOH, which is 10 to the negative 4.25. You'll need a calculator for that. On my calculator, I put in 4.25, change the sign, and press the 10x button. These numbers are small enough that we generally have to use scientific notation. So it's going to be 5.6 times 10 to the minus times 10 to the minus fifth. And the units on the concentrations will always be molarity. Some calculators you need to press the 10 to the x button first. and then put in the negative sign and the 4.25 and press equals. Any questions? We do this the same way we do it with the pH and the H+. So I just want to show you something. So we have these, oops, good grief. We have these relationships between pH and POH, and the hydrogen ion concentration and the hydroxide ion concentration. We can convert between these two in one, between the ones in this circle. If you start at any one, you can go to the next one in one step. Okay, we just learned this relationship between pH and POH. pH plus POH equals 14. So if I give you a pH of 10 and ask you what's the POH, well, it's 14 minus 10, or 4, because 4 plus 10 is 14. pH, to go back and forth between pH and H+, we know that pH is the negative log of the hydrogen ion concentration, or that the hydrogen ion concentration is 10 to the minus pH. And down here in the other corner, we have very similar relationships. POH equals the negative log of the hydroxide ion concentration, and the hydroxide ion concentration equals 10 to the minus POH. And we just did a problem like that. And then over here in this other corner, we've got the relationship from the equilibrium constant, that the hydrogen ion concentration times the hydroxide ion concentration equals 1 times 10 to the minus 14. So if you're given one of these values in the circle, you should be able to calculate any of the other values, or all of them. And you can choose which way you go around the circle. If I give you pH and ask you for the hydroxide ion concentration, there's two ways you could do that. From the pH, you could calculate the hydrogen ion concentration and then calculate the hydroxide ion concentration, and that would work. But this one is kind of messy. I like to avoid that whenever possible, excuse me, just because this one's so much easier. So you could also go from pH to POH just by subtracting from 14, and then do this calculation to find the hydroxide ion concentration. So if you start at POH, you can go to the hydrogen ion concentration. Either way, you choose which one's easier for you. If you're going from POH to pH, it's just one step. You could go 3 steps this way, but that'd be kind of dumb. Look at that, I changed the color of my arrow. Any questions? So this is the kind of the big picture of pH calculations. I think it's kind of cool, but kind of a geek, so whatever.